Okay, so now we're moving on to the second learning objective in section 3.3, which is about actually using dimensional analysis in order to solve these conversion problems. And, excuse me, you have on your handout this diagram that really goes through the steps of how you are supposed to do these problems. And so the first one we're going to tackle, and we're going to go through the steps on this, is how many slices are in 8 pizzas. And the reason we start with something that has nothing to do with chemistry is because I want you to do something that you already know the answer to. How many slices of pizza does the average pizza have? And I think most people will agree that it's 8. So you can probably just do this in your head. If you have 8 pizzas and each pizza has 8 slices, how many slices do you have? And you think for a second, you go 8 times 8 or 64. So I'm going to show you how to use this technique, which is going to be new to you, to answer a question that you already know. And then eventually, once you learn the technique with things that you may be more familiar with, you can use it for conversions that you aren't very familiar with. So step number 1 is to identify the conversion factor. So step number 1 over here is to identify the conversion factor. The conversion factor, remember from the previous video, was 2 quantities that mean the same thing, that are equal to each other but have different units. So the numerical value, the numerical part of it may be different, right? And so this is the idea that, of course, 1 pizza is equal to 8 slices. This is our conversion factor here. Okay. Then the second thing that we do is we set up the problem, right? We're always going to circle the do and underline the clue. That goes without saying. The question wants slices and it's giving me pizzas. And I write the known value out front, 8 with units, of course, right? Then I draw a parentheses. And usually, make them big because you're going to write a lot of stuff in here, or at least you're going to write a number and then some units. Making sure that the center line of the parenthesis, you're putting in a fraction. So you want to make sure that that sort of lines up with the bottom of that outside 8 pizzas. And then write each side of the conversion factor. This is where we are right now. Write each side of the conversion factor in either the numerator or the denominator, making sure that the unit up front matches the unit in the denominator. So see how this is pizzas. I know that what needs to go down there is also the word pizzas. And the reason why I know that is because I want them to cancel out. And when they cancel out, that means that my answer won't have the word pizzas in it, but it will have the word slices in it. So I take my conversion factor and put it in here. I'm going to put 1 pizza on the bottom, right? Because I need those 2 words to be the same, those 2 units to be the same. 8 slices goes on top. Okay, now we're moving on to the very bottom. Calculate the value of your answer, then check to make sure your units cancel out and that you have the right number of significant figures. We don't need to use significant figures in this case because nothing was measured. It was just all counting. So I do the problem once with the numbers and then once with the units. 8 times 8 divided by 1 is 64. This unit of pizza matches this unit. So just like with numbers, variables and units can cancel out the same way. Just as, 3x over 3, the 3's cancel. I know it seems weird, but the unit of pizza on the top and the unit of pizza on the bottom will cancel out. So the only unit that is left is 64 slices. And yep, that's the answer to the problem. So we did that with a conversion that you could probably do in your head, because eventually we're going to use dimensional analysis for, like I said, about half the problems this year. So the next one, how many hours are in 9,400 minutes? And so this is another one that maybe if you think about it for a while, you might have to grab your calculator. That's just fine. You could think about it and you could answer. But so I want us to do this using dimensional analysis here. Right? Question is asking about hours. It's giving us 9,400 minutes. So look at step 1, ID the conversion factor. What is the equality between minutes and hours? And it's 1 hour is equal to 60 minutes. Okay? Step number 2, write out the known value in front. 9,400 decimal point minutes. That decimal point is going to become important because minutes is something that we would measure. So there's going to be significant figures involved in this. Now I make a parenthesis, write each side of the conversion factor, and you have to pick it so that the unit out here matches the unit down there. So then 60 minutes is going to go on the bottom, 1 hour is going to go on the top. Therefore, the minutes units can cancel out. Now we're on to the very last step, which is to do the problem once with the math and then the other time with just looking at the units. So in my calculator, I'm going to type in 9400, 9,400, and then times 1, but we don't really need to put the times 1 in, and then divided by 60. And how many significant figures should my answer have? Well, this number has 4. These numbers, remember we said numbers that were defined don't have significant figures. They have an unlimited number of significant figures. So these don't count. I know that may be weird, but remember that significant figures are all about what instrument you use to make the measurement. There was no instrument that was used to make the measurement of 1 hour is equal to 60 minutes. We defined an hour to be 60 minutes long. So my answer is going to have 4 significant figures, and my answer is 156.7, and the only unit that I have left is hours. So there's my answer there. And now we can move on to number 25. How many kilograms is 352.2 grams? And this is your first metric conversion. So we talked about metric conversions on a few videos before, and this is the one with the kitten and the paper clips. So do you remember what the conversion factor is? It was, remember, 1 kilogram or 1 kitten is equal to 1,000 grams or paper clips. So that's my conversion factor. I'm taking 352.2 grams, putting it out front, taking the conversion factor and plugging it in. Since grams is out front here, I'm going to need grams in the denominator of my fraction. So 1,000 grams in the denominator, 1 kilogram in the top. And then again, I plug it into my calculator. So 352.2 divided by 1,000, and I get 0.3522. Those units, outside and bottom, should always be the same so that they cancel. And the only unit that is left is kilograms. And then I look at 4 significant figures. The metric, right? Both of these don't count for significant figures. Why? Because we defined a kilogram as being 1,000 grams. There's no instrument that was used to measure that, so therefore they have infinite number of significant figures. So 352 grams has 4, so my answer, 0.3522 kilograms, also has 4. So what conversion factors do you need to know from the metric system? So I just showed you one with the kilograms and grams. You need to know, and that's the only one where the unit is larger than the base unit of grams. A kilogram is larger than a gram, but all the others are smaller. So centi, milli, micro, and nano. This chart is in terms of grams. So here, I'll just highlight, right? See how this is grams here? All these G's could be completely rearranged or completely substituted out for liters, capital L, or meters, lowercase m. So this is the chart for the prefixes, but it could be any measurement that it is magnifying or reducing. You can have microseconds, right? You can have nanoseconds, but this chart is just in grams. And I'm pretty sure that you know kilo, centi, and milli, that you've used those before. But most likely these bottom 2 are new to you. So micro is It's difficult because when you think micro, you want to think that its abbreviation is an M, but that gets real difficult because milli's abbreviation is an M. So what is micro's going to be? Well, it's basically the Greek letter mu. It's basically the Greek letter M. It's like a U, but if you were writing a U, you'd write it like this. Think of a tail coming from below. You'll get used to it. It's kind of weird. Look it up if you're unsure of it. Like, look it up on the internet. So what does that mean? That means a million. That's a tricky too, because when we want to think million, don't we think of milli? Milli is 1,000. And think of like a millennium is 1,000 years. So milli is 1,000. And a million is micro. That's why I wrote it in, I wrote it not necessarily in scientific notation, but as the exponent 10 to the 6th, just so that you maybe remember the 6 part as opposed to the million part, because that sometimes confuses people. So micro is 10 to the 6th, and the last one, nano, is a lowercase n. So a nanoliter would look like a lowercase n and a capital L, or a nanometer is a lowercase n and a lowercase m, and that is a billion, so 10 to the 9th. And it's always, 10 to the 9th of the small unit equal smaller number, but larger unit, 1 gram. So these over here, these guys, yes, this means committed to memory by the time we have a test on this. So we're going to do a couple problems with these, and then we'll do some other conversions. So convert 4.77 millimeters to meters. Go back to the little scroll. What was the first step? Identify the conversion factor, right? The conversion factor for millimeters and meters. You can go back and look at the chart. It's 1,000, right? 1,000 millimeters equals 1 meter. Take the number that's given to us, 4.77 millimeters, and write it out front. Take one side of your equal sign and put it either in the numerator or the denominator, matching the units. So I'm going to put 1,000 millimeters on the bottom and 1 meter on the top, right? Because millimeters and millimeters, those guys need to be the same, because they're going to, the units, not the numbers, just the units are going to cancel out. Now I plug that into my calculator. I get 0.00477 meters, because that's the only unit that didn't cancel out. Double check for significant figures. This number has 3, and remember, conversion factors don't count. So if they don't count, my answer should just have 3 significant figures. And what a lot of students will do is they'll say 0.005. That's wrong, because these zeros are not significant. Leading zeros, beginning zeros are never significant. If you think you got this, again, try the next one. Hit pause, try the next one, and see how you do. If you want to continue along with me, that's great. This one is microliters to liters. So again, find the conversion factor. Go back. Micro is 10 to the 6. So 10 to the 6 microliters equals 1 liter. So 3.40 times 10 to the positive 4 microliters. What goes on the bottom? I need to make sure that whatever unit is here matches down below. So 10 to the 6 microliters, 1 liter. These units cancel. So now this is what I plug into my calculator, and I want to make sure that what you plug into your calculator is right. So it's going to be 3.40, and then you should see a small but uppercase E by pressing second comma, 4 divided by, and this you do not want to use scientific notation because there's no stem to this. So divided by 10 to the 6th. If you get that, you should get 0.0340 liters. And again, significant figures, this number has 3. These guys don't count, so my answer should have 3. That first 0 doesn't count.